Hello everyone and welcome to .NET Core Central. Couple of years back I did a video on Apache Kafka, but since then there had been a lot of changes to the Kafka, and also it has become really easy to install Kafka using Docker. So I decided to do another video on Apache Kafka, which is more recent and working with Apache Kafka with .NET 6. So first let's go through what is Apache Kafka. Apache Kafka is an open source distributed streaming platform. It is the most popular platform out there for streaming. The main reason we use Kafka to decouple an application through producers and consumers of messages. And it helps to not only distribute and scale out a system, but also allowing asynchronous processing of data for applications which does not need a real-time response back. Producers and consumers communicate event through something called topics, and topics are created in brokers. Brokers are nothing but servers where Apache Kafka is installed, and a Kafka can have 1 to hundreds of brokers running in a single cluster. Kafka is highly scalable, and also it is highly available through replication of topic, which is something we'll discuss a little bit later in the video. So one of the important topic of discussion is topic and partition. So a topic can have multiple partition, and how many partition a topic can have is decided during creation of the topic. So in this diagram, what I am showing is a single topic which has three different partitions: partition 0, partition 1, and partition 2. And then on the other side, there are 3 different consumers. Now each partition will have messages coming in from the producer who are going to publish into the topic. And every partition will have a number for the message, which is known as the offset number. And it starts from 0. But each partition will have its own unique number. But that doesn't mean the messages in the partitions are same. The message which is published into partition 0 is going to be only for partition 0 and not for partition 1 or 2. And messages inside of a partition are always in the order of how they were published. And the data that is written inside of a partition are always immutable, meaning you cannot go and change the data after it's been written, which is obvious, and it is the same for other streaming applications as well. The data has a lifetime. For example, the default lifetime of data in Apache Kafka is 7 days, but it can be changed. Next, in the previous diagram, here we had 3 different consumers of the same consumer group. What is a consumer group? It's essentially an application scope. So for example, let's consider that we have a topic for weather data, and the weather data topic has 3 partitions. Now, a consumer group is an application which can have multiple consumers, but all the consumers are executing the same logic. Meaning, if we have 3 consumers, they have to get data from 3 different partitions, and they cannot have duplicate data, because they are part of the same application. It's just three different instances of the same application. And that's where you use a consumer group. Now we can have multiple consumer group listening to the same topic, and the data that is published into the topic will be given or will be read by all the consumer groups. But within a consumer group, the data read by a consumer will be unique. And this is what this picture tries to show, is that here for consumer group XYZ, for example, let's say it has three consumers. Now three consumers in this case will be attached to three different partitions. But for the same consumer group, for example, if one consumer dies out, or we create only two consumers, in that case, the three partition will be shared by the two consumer in the consumer group. But in another example, let's say for the same topic and same number of partition, we have two different consumer groups. One consumer group has three consumer and the other consumer group has only two consumer. In that case, the consumer group with three consumer will be connected to all the three partition, one consumer per partition. Whereas the consumer group, where we have only two consumer, one partition will be going to one consumer. For the other two partition will be going to the next consumer. Now which consumer goes to which partition, it's managed by Kafka, and it is not deterministic. It is based on the algorithm which is implemented inside of Kafka. So based on this, as you can understand, consumer group is something is used mainly for scaling out. So if you have multiple partitions, then you can scale out your consumer to match the number of partition to execute faster. Whereas you will have different consumer group for accessing the same set of data, but for different implementation or different outcome. That is how you have to look into a consumer group. Next, as I mentioned earlier, we have the concept of broker. And broker, as I mentioned, is nothing but a running instance of Apache Kafka. So you can have one or many broker. In a standard implementation in a production environment, you should have at least 3 brokers. In the examples that I'm going to show here, I'm going to have only one broker because I'm going to install it in my machine. Now here, let's say we have 2 brokers and we have created 2 topics. One topic has 2 partitions, one topic has only 1 partition. In that case, what is going to happen is for topic 1, which is 2 partition, will be created both in broker 1 and broker 2. Whereas topic 2, which is only 1 partition, will be created in one of the broker. Apart from what we discussed so far, there is one other very important feature which topic has, which is called the replication factor. And replication factor is extremely critical for Kafka to support high availability. Now, when we create a topic, we can set the replication factor. The replication factor essentially provides how available a topic is going to be. For example, here is a visual representation of a scenario where topic 1 has a replication factor of 1, but topic 2 has a replication factor of 2. But topic 1 has 2 partitions, topic 2 has only 1 partition. Now here, topic 1 has 2 partitions, so it is in 2 different broker, but it has only replication factor of 1, which means the partition will not be replicated in other brokers. Whereas for topic 2, it has only 1 partition, but it has a replication factor of 2, which means it will be replicated in two different brokers. Now, what will happen in an event where one of the broker goes down? The topic 1, partition 1, for example, if broker 2 goes down, for topic 1, partition 1 will be inaccessible at that point in time. But for topic 2, the partition 0 will be accessible because broker 1 is going to be up. Similarly, if broker 1 goes down, for topic 1, partition 0 will be inaccessible. But for topic 2, partition 0 will still be accessible because broker 2 is up. That is why replication factor is extremely important. Ideally, the replication factor of a topic should be at least 3, so that in a scenario where one or even two broker goes down, you will still have the data in one of the broker and your application will not be impacted. Here, if we would have set replication factor for topic 1 as 2, then the topic 1 partition 0 would have had a replication copy in broker 2, and similarly topic 1 partition 1 would have had a replication in broker 1, which would have made the topic 1 also more reliable. Now that we have covered the theory, let's get into and try to show you how we are going to install the Kafka. So for installing Kafka, I'm going to use the Confluent Kafka implementation. And for that, we can download the Docker Compose YAML file. Now I already did that, so I'm not going to run this, but this curl command, which I am going to put it into the description of the video as well. But this curl command is going to download the Kafka Docker Compose file. Now, once we have downloaded this particular Docker Compose file, we can run a command called docker-compose up-d. So this command is going to run the compose of the Docker Compose file, and then it will create all the necessary container for us. So if I do a docker ps, it is going to show all the images that are downloaded and container created by this particular command. So here you can see it has an enterprise control center, and this is something I'm going to show how it works. This is very handy. It's a visual representation of the Kafka cluster. Then it creates KSQL DB, which is a database for Kafka, and similarly the CLI and the server. And then it creates a Kafka schema registry, Kafka server, and Zookeeper. And Zookeeper is something which is a key value pair server, which is used by Kafka to manage the brokers and then electing the primary in a broker cluster. Now, if you have only single broker, it's easier. When you have multiple broker, the Kafka needs to select a primary, which will be the one where every request will come in, and then it will be replicated across multiple brokers. Now, having said that, now that this is running, let me show you, going to the port number 9021, how the administrative application or the control center of the Kafka looks like. So this is the control center which is installed, and it is Confluent because we installed the Confluent Kafka. And you can see that the cluster is running. It has only one broker and it has multiple topics, and all these topics are basically the topics that are created out of box by the Kafka installation. And for consumers, these are right now just out of box consumers. Now, if we have to create a topic, there are two ways to create a topic. One way is programmatically, or we can create topic using this particular control plane. Now, the advantage of using this control plane is that there are a lot of features which it supports, which the normal program in C# does not support. But if we use the CLI, we should be able to have all the properties that this particular control plane supports. So when you create a topic, for example, let's say test topic, here we can provide how many number of partitions we want to have. So we can have 2 or 3 or whatever we want. And similarly, we can use the customize settings. And here is something which is important, is the replication factor. So by default, the replication factor is 3, which means the topic will be replicated to 3 different brokers. Now in this case, in my PC, there's only one broker, so this really does not matter, or it is not that useful. But in a production scenario, replication factor becomes extremely critical. So I'm not going to create the topic yet, because we're going to create the topic later. Now let's open up the producer and consumer. So I created this code for producer, but I've not implemented anything yet. And if we go to the NuGet package, you can see I have installed the Confluent.Kafka, which is the NuGet package necessary for connecting to Kafka. And then I also installed Newtonsoft.json, which I'm going to use for serialization, the string message. So now for the producer, what we can do, let me just add so what we can do is we can say var config is equal to new producer config, and this is where we are going to provide all the configuration that is needed. So for us, the most important configuration is the Bootstrap Server. And for the Bootstrap Server, I'm just going to provide localhost colon 1992, because this is where my Kafka server is running. If you remember, the Kafka server is running here under 9092. So this is where we are going to connect. And then it has a bunch of other properties. Most of the properties are not that critical, but one thing which is important is acknowledgement. This identifies the number of acknowledge the leader broker must receive before responding the request. Means here we can specify, do you want only one, which means just the leader comes back and says, so let me first show it. So this is the option. The option is selecting leader, which means as soon as leader gets the message and writes it, this response is going to come back. Other option is all, which means the request will wait for all the broker in the cluster to acknowledge that they have written the data, and then it will come back, which is not very efficient for most cases. And the last is none. Don't wait for anyone, just come back. The better solution, especially in a cluster with multiple broker, will be just relying on leader, and as soon as leader acknowledge, we should be good to go. So for this example, I'm not going to set anything up. After creating the config, now we are going to use the producer builder to build the producer. So for that, we can say using var producer builder, and for producer builder we are going to pass null as the key and string as the value. We're just going to pass the value, and then after that we can pass the config. and then dot build. So this is going to build a new producer, and we can create a try catch block. And here we can say what we want to do is we want to send messages, and for that we are going to use the method produce async. So we can say var response is equal to producer dot produce async. Now as you can see, there are two methods, one is produce and one is produce async. Produce async is a more modern and better implementation, and produce async is going to return the response from which we can figure out if it is success or failure, whereas produce is going to return void, but it has a delegate handler which we can use to find out what is the delivery report. But for our case, we're going to use produce async. And for the produce async, the first thing we can pass is the topic. So we'll pass a topic name. Let's say the topic name is weather topic. And the next one is the message. So for message, we can say new message. And for the value, we can pass hello Kafka. Now what we want to do is we want to run this particular not just once but multiple time ideally. So for that what we can do is we can do a while, and in the while loop we can say console.readLine. And let's do one thing, let's create a weather class also, or a record. So we can create public record weather, and let's say it's a string zip code, and then instead of zip code just let string state and integer temperature. And ideally this data should be coming from some external service, and the producer should be then producing into the Kafka topic, but for the time being we'll just hard code. And here what we can do is we can say string state, and we can say state is equal to console.readLine, and if this one is not equal to null, then we want to keep sending message. And here for the value what we can do is we can say, and this is where we want to use the new weather, but given value is a string, we can use a JSON convert.serialize, or we can use weather object itself here. For the time being, let's just pass the serialized string instead. So we can say JSON convert dot, we have to add the namespace. So JSON convert dot serialize object. And for the serialize object, we can here use new weather, and for the state we can pass the state. For temperature, let's say it's 70 degrees Fahrenheit all the time. And then here for the exception, we can actually have appropriate exception. So we can have produce exception string exception, and then here we can just have console.writeLine exception dot, yeah, let's just log the exception.message. So this is the producer. Now the producer has to be running fast because the producer is going to create the topic in this case. And then we have the consumer. So first let's finish the consumer programming. And for consumer also, for the NuGet package, I can just show the NuGet definition here. For the NuGet package, we have confluent.kafka and newtonsoft.json. Now for consumer, we're going to do the same thing. First using confluent.kafka, and we can also do using newtonsoft.json because we'll need both of these. And then we can say var config is equal to new consumer config. And for consumer config, we need the group ID. As you remembered, we discussed about consumer group, which is extremely important. Consumer group is the one which is where distribution of different partition of the same topic will depend on the group ID and the number of instances for that group ID running. So here, let's give it whether consumer group, and then we need the Bootstrap server. So for Bootstrap server, we're going to have the same thing, localhost colon 9092. And then finally for the auto offset reset. So auto offset reset, as you can see, is action to take when there is no initial offset in the offset store or desired offset it out of range. So if there is no offset basically in offset store, then we want always the earliest. So that's about it for the config. Now we can create a consumer, and for using consumer, we can say using var consumer is equal to new consumer builder and now and string, and we can pass the config and then dot build. So this is going to build the consumer, and then we can say consumer.subscribe, and we are going to pass the topic, which is weather topic. If you remember, this is the topic we defined here, weather topic. And then we need a cancellation token, so we can create cancellation token source token is equal to new, and after we create the cancellation token source, we say inside of a try catch block, we are going to consume the message. So we can create try, and then here inside the try, first we are going to do while true, and then we can have var response is equal to consumer dot, and this is where we're going to have consume, and we can pass the cancellation token that we created dot token, and then if response dot message is not equal to null, then we can create var weather is equal to, and I need the weather object here as well. I'm just going to copy and paste it right now. Ideally this can be put in a separate NuGet package, but for here we can just do that. So we can say JSON convert dot deserialize object, for the object will pass weather, And then for this one we can say response dot message dot value. This is essentially the response message. And then finally what we can do is, after we got it, we can say console.writeLine, and here we can say city with the dot city state. Sorry, we are just showing state. So state is equal to this, and then we can say temperature is weather dot temperature Fahrenheit. So that's about it. Now if we run the broker fast, it's going to throw an error because this topic is not created yet. So there are two ways to do it. Once, as I mentioned, we can create the topic through CLI or the control pane, or we can run the producer fast. So in our case, we're just going to run the producer fast and create the topic. So the producer started, and then I'm going to pass ny as the state. Now let's put a breakpoint here and run it, and then comes to the read line, we pass ny, it comes here, now one thing we missed is we have not written the response from the response message. So let's write it. Though it has already published the message, but it's not writing any response, so it's hard to understand whether it was a success or failure. So we can do console.writeLine, and here we can do, after for the write line we can do response dot value. So it's going to say the value is written or not. So we don't need the breakpoint anymore. Let's run it and pass nj, and we can see it is writing the object because it was successfully delivered. Now let's go back to the consumer and run the consumer, and for the consumer we should be seeing 3 different messages coming up because we sent 3 messages. Now once the consumer starts, let's go to the producer and send a message here, ny, and we should be let's see what is going on with the consumer. Let's run it. Now the message came here, and then if we do an F10, the message is showing up as null. Let's see response value. Message is not null. I have a bad code. I said message is equal to null. It should have been message is not equal to null. So let's change this and run this. Now it should show all the messages. So the consumer is up. Let's go to producer. Let's type ny, and we should see ny message showing up. And we did message is not equal to null, then get in. Let's put a breakpoint. There's definitely something else going on here. Let's pass nj, it's not null. And message.value, yeah, looks like it is coming a little delayed. So it printed out 2 of the message back to back. Now let's send another one. Now it is coming instantaneously. Initially it took some time. Okay, so as you can see, the message, the producer is producing message and it is showing up in consumer. And as you can see, the code is pretty straightforward on how to write both the producer and consumer. So this is at a very high level. Now if I go here, I go back to the topic, I can see the weather topic showing up here, and it shows it has 3 message consumed. And then if I go to the consumers, I can see the weather consumer group showing up, and the number of consumer in the group is 1, and number of topics is also 1, and it is not behind any message in terms of any messages. So that is the very fast introduction of the Kafka with the new control plane and Docker implementation. In the next video, I am going to cover how we can use multiple partition for a topic and how does that impact with running multiple consumer. And also I'm going to take a real life example of getting data and processing data in the producer and sending it to consumer, and then consumer consuming the data and saving it into a database. So that's all I wanted to cover for today's video. If you like this video, please give me a thumbs up. And if you're new to my channel, if you think you are getting value out of my channel, please subscribe to my channel. And thanks so much for watching this video.